Good evening, guys. Welcome to Builders Online Academy. Thanks for watching our videos online. Please do subscribe. Please do press subscribe button and notification bell. To update on this YouTube channel. Today, I'm going to be talking about Cambridge IGCSE exam, specifically on the subject chemistry and the theory aspect of the questions. And I'm going to be taking us through some questions as we are going to be solving it together in order to prepare in anticipation towards the upcoming exam in IGCSE, and this is 2023 examination. The first question before us here is this. We are going to be zooming out. Okay, we have the first questions here. As you can see, let me a little bit of zoom out. Okay, now here is the first questions on the theory aspect. We can see an electronic structure of A, B, C, and D. This is what we call electronic orbital configuration of an atom. Electronic structure of 5 atoms A, B, C, D, and E, as shown in the diagram. Answer the following question about these electronic structures. Each electronic structure may be used once or more than once. It can be used once, more than once, or not at all. State which electronic structure A, B, C, D, or E represent. Now we have to state what this electronic structure A, B, C, D, or E represent. Now, first of all, you need to interpret this. We can see when we're talking about electronic structure. Let me just give you a little bit of introduction. We know that in electronic structure of an atom, the first circle here, we call it the orbital aspect. The first circle here, the first circle is known as the S, or the S circle, which is known as the K, and it usually takes 2 atoms. This one take 2 electron radars, and others take 8, and so on and so forth. So the first one take 2, and the others the rest take 8. So here, counting, you can see for this small one you have 1, 2, and then we have another. This first one is 2, as like I said, this is 2. The next one takes 8, as you can see it here. The next one you also take another 8, and then it takes 1. So meaning that here we have A is equal to 2 plus this. A is equal to 288, 2, 8, 8, 1. So this is total. In total, this one is 19. In total, it has atomic number of what? 19. That is, the proton number is 19. This actually will be potassium, because potassium is number 19. But let's leave it like that. So that's potassium for you. Now this one is 2. Let me pick another color to indicate that one. Let's use green so that to differentiate. This one is actually 2. This one is 1, 2, 3, 4. We have 4. So we have B to be 2, 4, and the total electron here will be what? The total electron here will be 6. And is it oxygen? Oxygen is number 8. While carbon, this should be carbons with atomic number of 6. This one is potassium, 19. So this C here will be, let's use another color. This one is 2. This one is 8. This one is 1, 2. So 2, 8. Then we have 1, 2. Another 2, which is 12. So we have 12. So we have 2, 8, 2. So we have 12 atom. And number 12 should be magnesium. Magnesium is number 12. So that's that. Then we move to this one, which is 2. We have 2, 8. Then we have 1, 2, 3. 3 here. So we have 2, 8, and then 3. That is 13, which is aluminium. Aluminium is number 13 on periodic table. And then the last one is the last one, which is DE. So let us use black. So this one is 2, this one is 1, 2, 3, 6, and then 7. We have 2 and then 7. So this one is likely to be, this one is 7, that is fluorine, which is total of 9. We have 2, 7, which is 9, total of 9. So fluorine, we have potassium, carbon, magnesium, but we are not asked to use this word atom. They give us in terms of APC, so be conscious of it. Always use what you are asked to use. Now, state the electronic configuration, state the electronic structure of A, B, C, D, or E represent. State which electronic structure A, B, C, D, or E represent. You can see A is actually 2881, which is 19, that is potassium. B is 24, as you can see, 2 and then 4, as I have indicated here, 2 inside, 4 outside, that is carbon. And then we have C, 282, magnesium, that is 12, magnesium, that's how I denoted it. And we have D, which is aluminium, 283, and then we have E, which is fluorine, 9. So that's that about that. So now we are now an atom in group 2. An atom in group 2, that is the one that has 2 in its atomos shell. The one that has 2 in its atomos shell, that is magnesium, that is C. So an atom in group 2 of the periodic table is what? An atom states, okay, that's what they are trying to say now. State which electronic structure will be represented. So an atom in group 2 of the periodic table will be what? So which atom has 2 electrons in atomos shell? This is an atomos shell. The atomos shell, this one has 2, 1, 2. C has 2. So its C is belonging to 2. So we have C to be in group 2 because it has 2 in its atomos shell. So now, as the answer is C. Now an atom with proton number of 13. An atom with proton number of 13, that is D. You can see here 2, that is D. That is D. That is Mr. Yellow. So 283. That is the electronic configuration. That is D. So an atom that forms a stable ion with a single negative charge. An atom that forms a stable ion with a single negative charge. A stable ion with a single negative charge, and that should be with a single negative charge. That form a stable one with a single negative charge. That is fluorine. If you go to fluorine, fluorine is actually having 7 with remain 1 to complete, which is 8. So it's chlorine, which is E. Why? Because it's not chlorine, I mean fluorine rather. Fluorine is 27, which is number 9. So it remains 1. If you put 1 to it, to become 28, and then it will form an octet structure with a negative what? With a negative charge, just like I wrote it here. If you attach an extra electron in an atomos shell, it will be completed as octet structure, but it will going to be carry negative because it had an electron to itself. So now that is E fluorine. An atom of a non-metal that forms a giant covalent structure, that is carbon. Carbon is a non-metal but form a giant covalent structure. That is one of the property of what? Carbon. So the answer here is specifically Mr. Carbon. C. Okay. Specifically Mr. Carbon. No, so carbon is carbon is number is B, which is B. That is carbon is B. So you have to represent it as B, not, don't write carbon, please. They didn't ask us to write carbon, they just use that letter A, B, C. So an atom of a metal used in food container. Wow. So that's an aluminium can. So we use aluminium to what? Very well in what? In storing food such as drinks. They use aluminium. So that is, don't write aluminium that I can see I'm about to make that mistake. No, please don't make that mistake. That should be D. So that's that about that. So let's quickly do this one as well. So we have complete the following table shows the number of electrons, neutrons, and protons in the vanadium atoms and the calcium ions shown. So we are how to show. So these are other typical questions that we have to solve in B. So we have that has to complete the table to show the number of 1 electrons, number of protons, and number of neutrons. We have to show these three in the vanadium and then in what? In calcium ion. So we have the vanadium, and the vanadium has number of electrons to be 23, and number of also vanadium, you can see vanadium here. Vanadium has 51, 23. We are asked to show number of electrons. Now you have to know that when calculating this, let me do it so that we can have more space. So we have 51 and then the 23. So normally atom is generally represented as X. Any atom is represented as X with mass number on the top, mass number. Some people call it what? Mass number, relative atomic mass. If they didn't call it a relative atomic mass, while this one is actually the atomic number. Atomic, not something that you see there here. It's atomic number. Let me denote it very well. Some will write it as M, X, A, and then Z. This one is atomic number. This atomic number is shown as what? The proton number. So what I mean by that is this A here is noted as mass number and this atomic number is noted as Z. So meaning that whenever I see this 51 here, it is the mass number of the vanadium. And then this Z here is the what? Atomic number, which is the what? Note that A is the mass number. That's what I'm trying to say. I don't want to repeat. A is the mass number, which is known as, some people call it what? Atomic what? Mass. Atomic mass. They actually take it as atomic mass in most cases. And then Z is the what? The atomic number, which is also known as what? The proton what? The proton number. The proton number. Please follow. The mass number, the atomic is same, and then the atomic number is the same thing as well, the proton number. Then there is a relationship between mass number and the what? Proton number. So mass number equal to proton number plus neutron N to give us what? That is neutron. So N here, I can say that N is neutron what? Neutron number. You have to follow my handwriting to follow on my voice. Neutron. So this is a formula you need to remember. Very, very essential. That is A is equal to Z plus N. A equals Z plus N. That is mass number is equal to proton number plus Z number for a neutral what? This is very, very important for a neutral charge. And also you should know that for a neutral what atom rather. So no, for a neutral atom, let me even write this one. For a neutral atom, that is atom that does not have charge, just like this. For neutral atom, the number of proton, which is the Z, is equal to the number of electron. The number of proton is equal to the number of electron. My E here is representing what? Electron. That's why I put minus on it. So in a situation like this now, if they say you should calculate number of proton, this vanadium is not having a charge. We have vanadium 51 and then 23. Vanadium 51, that is mass number 51. Mass number 51 and then atom number 23. It does not have charge here, meaning that what? The A is 51, the Z was 23, And because it does not have charge, it's a neutral charge, it's a neutral atom. So definitely its electron is also 23. It's a neutral atom. So this one will be what? The atomic number is 23. Don't forget, atomic number is same as the proton number. Atomic number, proton number, which is Z. So if it is Z is 23, definitely the proton number here is 23. Don't forget this atom. And then because this proton number is 23, the electron number is also 23 because it's a neutral atom. Did you get that? You can see proton number is 23 and then the electron number is 23 here as indicated here because it is a neutral atom. Now we can now successfully calculate our number of neutrons using this formula. So neutron will now be using this formula Z plus N. Z plus N. We now what's our A? A is 51 equals to Z 23 plus N. So by just normal subtraction methods, we have 51 minus 23 will give us the number of neutrons, which we can easily place on calculator. So we have 51 minus 23, 28. So that's that about the number of neutrons for the vanadium. So we have what? Calcium, right? Calcium, now the number 2 is calcium. Let me just change the color. Calcium, you can see this one is a little bit different because calcium is a charged atom, unlike this neutral atom that has 0. The neutral atom always have nothing, which is taken as 0. It's taken as 0 as a charge. So this one is having a mass number of 48 and this one is having what? Atomic number of 20. So definitely calcium atomic number, you can see mass number can actually vary. That's the difference here, but atomic number is always constant. So you can see A here is 48 for calcium and the Z is 20 This is very, very delicate because here the proton number is 20 because proton number is same as atomic number, so this is 20. But the number of electrons will be different here for a charged ion. So that's why I will now do another formula for number of electrons for charged atom. That is, when they say something is charged, it's having positive or negative on its on its atom. It's having a charge or whether positive or negative on its atom. Like this, calcium is having 2 plus 1, 2 plus 2 plus 1 plus 2. If it is chlorine, charged fluorine, it will be minus 1. So if it's having a charged for a charged atom, 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 the number of electron is equals to Z, that is the proton number minus the charge, minus the charge, minus the charge, minus the charge, minus the charge number. I put in the bracket because there are sometimes it has positive or negative, minus the charged atom, charge number rather, minus the charge number. So number of electrons is equal to proton number minus the charge number. So we have Z. What is Z? Z now for this is 20. 20 minus the charge on top is plus 2. So it is plus 2. So you can see that's the essence of that word bracket, so that it can actually multiply it out. So this one is going to be what? 20 minus 2, because plus times minus is going to be minus 2. So of electron now will now be so 18. So we have 18 here. So we have 18 because it has loose what? 2 protons is going to, because it has those 2 electrons, it's going to be 18. So that's it. So that's that. And then if you calculate 40 minus 20, you get